Hello. Hello. Um, right. I think now I should be audible. We'll just wait for a few minutes and then we'll begin. Yes, Madam. You can feel free to type in the chat box as well. All right. I guess so we can get started with today's session. So as usual, I'll give an introduction to what session this is and what to expect from this session. And of course, if, all of us know that this is a weekly session for the NPTEL course Advanced Computer Networks. And this is the week 7 of the live interactive session. And every week we have 2 such sessions that happen. So we have one on Friday and the other one on Tuesday. So as test takers or as people who have taken this course, you can choose to attend either one of these sessions, or alternatively these sessions are recorded, so you can possibly look at it in the YouTube channel with a higher speed if you want to save your time, right? Or if you have any questions, you can join and you can ask also, right? So this is more of a discussion and interactive session where we try to learn from each other, let's say, right? And of course, so what is expected in these sessions is we look at some previous questions. We look at 10 questions every week and we solve these questions, right? And while solving, we look at the associated concepts as well that are asked in the questions, right? So I believe this week it must have been purely about network function virtualization, or in other words, NFV, right? Or NFV. Can excuse me for my lack of enthusiasm today because my health is not that great. So I will be a bit slow today. All right. Okay. So as usual, I think since the third meeting I started doing this, we will go through the questions and we'll identify the keywords and then we'll go based on these keywords. Okay. So the first question is, which of the following challenges is associated with network function virtualization, right? So what's this keyword? It's network function virtualization. Just 1 second. Network function virtualization. So which of the following challenges is associated with NFV? We'll see the answer later. Right? Is it A, is it B, is it C, or is it D? Right? So the next is what is a bump in the wire? Right? So this is also not a technical term, but it's an interesting term. In the wire. Right? It is actually more of a colloquial term. So it is a disconnected network for middle boxes. So we'll also look at what these middle boxes are. Right. So I think these are the keywords in this question. Third is, what layers of operation does the NFV address? So by what layers? They're talking about the network layers. Sorry, with the OSI or whatever, the network stack you can say, which is application, presentation, session, transport, and all of those. We'll come to that. Okay. So which are all these things that the NFV tends to virtualize? Right. So we'll find out what NFV is again, and then we'll figure out which are the layers that it affects. That it affects. Okay. And so this is what is network function virtualization. What is NFV on a whole? What is this NFV? Right. So we'll look at that. Is it a protocol that is used for wireless communication between devices? Or is it a technology that virtualizes network functions into software? Or is it a technique used to encrypt network traffic for security purposes? Or is it a technology responsible for monitoring network traffic? So we will look at it. Right. So now here, what is the difference between network function virtualization and software-defined networking? Right. So if you remember, we studied software-defined networking in the last classes. Okay. Again, we have this network function virtualization here. So NFV is focused on separating the control and data planes in a network, while SDN is focused on virtualizing network functions. Or is NFV focused on virtualizing network functions, while SDN is focused on separating the control plane in a network? And NFV and SDN are the same thing? Or NFV is a hardware-based approach, while SDN is a software-based approach? We'll find out what the answer is. So which of the following statements are correct about network function virtualization? Again, network function virtualization. So does network function virtualization eliminate the need for hardware changes when network requirements change? Is it true or false? Let's take a look later. The role of a virtual network function. So you see this, there's a new term, virtual network function. In NFV, of course, once again, is to centralize network control in a virtual environment. Or is it C, network function virtualization is the ability to run multiple virtualized network functions on a single hardware? Or is it D, virtual network functions enable network operators to implement network functions using dedicated hardware devices? Now we'll figure out. So the following is not a primary function of the operation support system. So these questions are very highly theory based. So we'll just have a brief look over these things. Okay. Operation support system. Is it fault management? Is it configuration management? Is it customer management, or is it performance management? Right? And which of the following statements is /r true? Okay. So virtualized infrastructure manager is a part of the NFV management and orchestration layer. So there is this layer called the Mano layer. Mano layer, which is called the management and orchestration Mano layer. And or is it the network function virtualization management and orchestration layer is responsible for managing the physical network devices? Or is it that the NFV infrastructure manager is responsible for providing physical resources for the virtualized network function? Or is the management and orchestration layer responsible for providing the virtualization layer in NFV architecture? Right. So again, we see a lot of places where NFV is repeating NFV, NFV. Mano is okay. We'll take a look later. And again, if a function virtualization component is which of the NFV component is responsible for automated provisioning of virtual network functions? So there's this another concept called not another concept. It's NVNF, and this is appearing twice. Okay. Again, which of the NFV component is responsible for managing the lifecycle of virtual network functions? Is it the operation support system, or is it the virtualized service manager, or is it PNF manager, or is it the virtualized infrastructure manager? Right? So now we have a list of all the keywords. Now let us take a look at all these keywords one by one. And then finally, towards the end of the session, we'll answer all these questions. Okay. So let's take a look. Right. So we just saw that almost these are all the keywords, right? Network function virtualization, bump in the wire, middle boxes, software defined networking, virtual network functions, operations support system, and Mano. Right? This is a part of a architecture from ETSI. ETS. I think ETSI. Correct. Let's see. So let's have a small recap of what we did in the last week, and then move on to what is happening this week, so that you'll have the context in your mind. Right? Recap. Week 6. Software defined SDN. So as a part of software defined networking, the key concepts that we saw were the separation of the control plane and the data plane. Right? So there is this control plane and there is this data plane. Okay. So in the traditional networking, if there are 4 switches like this, each of these switch will have a control plane, data plane, control plane, data plane, control plane, data plane, control plane, data plane. Okay. So the control plane is disaggregated in the sense it is distributed across all of the devices. So now in the paradigm of software defined networking, which is otherwise called SDN, we have these devices and there is a common control plane, but there is only the data plane. Right? This control plane tends to communicate with all of these. Right? So the point that I'm trying to bring out here is the fact that the control plane does not alter the network stack. When I say network stack, it is the layers. You can either say there are 5 or 7 layers as per your, but actually there are, consider the lower number, right? So it does not alter the network stack in the sense, this is a way in which you manage these devices. We can manage and control these devices. These devices, I mean, control network devices. Right? And this was, I think, this is the nutshell of what happened the previous week. But this week, we have something called network function virtualization, NFV. The whole week is about NFV. As you noticed, we saw 4 to 5 instances of NFV keyword in all the questions, almost 5 questions had NFV in it, right? Okay. So what is this NFV? In a nutshell, if you want to answer this question, the answer is it is a technology that virtualizes network functions into software. Okay. Now there are again some keywords here: software, network functions. Right. So we have to define what are all these things. What is a network function? And what is a software? Right. Okay. And of course, virtualizes. Those are 3 keywords here. Right. Let us start from the bottom. What is a software? It is program written by, let's say, of course, programmers. That is compiled slash interpreted compiled or interpreted and run on for CPUs. Okay. So for example, you write some C code. The C code is compiled and it becomes an executable, correct? And this executable runs on your CPU. Right? So because all of this is running on general purpose hardware and this CPU is general purpose. And what this general is you can basically do anything on the CPU. You can write programs, or you can watch videos, or you can play games, or you can do development. You can pretty much do anything. You can edit videos. You can do anything that you want. That's why it's called general purpose. But if you take a switch or a router that also has a CPU, a processor, right? But it is not general purpose. Why? Because it is specialized from only some operations. Right? It is specialized to perform only some operations. Okay. Now let us come to network functions. So what are these network functions? Network functions, I'll get to the point directly and then I'll explain. Right? The network functions are nothing but operations that aid or concern the network. And what could those be? They could be things like router, firewalls, load balancers, intrusion detection and prevention systems, or application delivery controllers, etc. So it could be any one of these things or even more than this, right? So let us look at some theory about how NFV came up to be, and let us move forward from there. Right. So if you look at this diagram, it's a router, there is a CDN, let's say, there is a firewall, there is a deep packet inspector. Okay, these are all separate devices. These are all separate devices. Now, what network function virtualization does is you bring your own computer that is called commodity hardware, right? This could be your own PC or some server, right? And what you do, you take the logic that is done by the router, but you write it here. Make it virtual router. Take the logic of the CDN and make it virtual CDN. You take the logic of firewall and make it virtual firewall. Then you take the logic of DPI and make it virtual packet inspector. So what is happening here, what is important to note here is that you are taking functions that are happening inside a network, okay, and you are writing their equivalent code. So router becomes virtual router, right? So you're taking the function of the router. Router has some function, right? What is that function? It is routing. Routing is the function. So router has a function, and you take this function and you write your own code. I'm explaining in a very layman's way, right? Code. So if so routers, what does the routing function do? It has a table, and based on it, every packet comes in, it matches, then it sends out. So you write your own code for it in, let's say, C/C++. This is not what happens, but generally I'm saying C++, and then you compile it and you run it. Okay, so where are you going to run it? On commodity hardware. What is a commodity hardware? It has general purpose CPUs. Okay, so you have the same function replicated as code, and you're running it on general purpose CPUs. But if you notice, a router is supposed to be kept inside a network. Okay? So where does the router stay? A router stays in between links like this, right? So this is a router. But now, because the function of the router is in your hands, right? You wrote your own code, you have it in your hands, right? But as a software, so all the logic that you wrote here runs on the hardware of the router. But now you have a software. So now what you will do, you will take your computer, this computer, and you will put it here in the space of the router. Okay. So when you do this, what happens? You have packets that are coming that hit this router, that hit this router, sorry, and the router does its job. But since the same logic is there on this machine also, it will do the same thing. It will take it and put the packets here, similar to what happens in the actual case. So essentially, what you're doing is you're taking the logic from specialized hardware and running it on a CPU, which is basically commodity hardware. Right. So you have created two routers by yourself now. Let's say you have a laptop here, you place one laptop here, you place one laptop there, and let's say the laptop has two ports, and you basically are doing routing by yourself now. Right. It's just a very layman's example. So in the end, what has happened is the router is pretty much taking care of routing, right? Layer 3. But now this system or this laptop is also taking care of layer 3. Right? Same function I'm doing here and there. The point to note here is this method will be slow. Will be slow. Why it will be slow? Because this hardware is not specialized for packet processing. Right? It's a normal CPU. And the CPU is designed to do many things other than packet processing also. So you will not get the same speeds in this case. You will not get the same speeds. But in essence, as a functionality, you have created your own virtual network function. You have created your own virtual network function. Okay. Right. Just give me one moment. You have created your own virtual network function. So essentially, what did you do? We basically took the logic from a specialized hardware. And this specialized hardware that did some network function. It did some network function, right? But what did you do? We took this the logic of this network function, and what do we do? We ran it on my computer, let's say. In my computer, I am also running the same network function. But the only difference is this is running on a different platform. And I have more control over it because this is just code. So if I change the code here and recompile it and redeploy it, then it might become network function 2. Okay. Might be network function 1 or 2, right? So by 1 or 2, I mean you can modify it. So basically you can rapidly change things and also make new network functions. That is what this is. So basically what we've created here is a virtual network function, correct? And when you talk about these specialized hardware, right? The specialized hardware, we basically have also call them middle boxes. I think middle boxes, I've spoken about it at length in previous classes also, but we'll take a look at it here as well. All right. Right. So you can, in a way, you can say that network functions are deployed by middle boxes. All right. So these network functions are deployed by middle boxes. So let's look at a typical network diagram. This is also there in the lecture that you might have seen this week. So let us say that you have switch, right? And you also have a firewall here. And this firewall is running on top of the switch. Okay. Now this is one unit. Now you're having traffic that is incoming. And next to the traffic might go to an IDS / IPS, which is an intrusion detection system or an intrusion prevention system. Right. So this is another specialized hardware. Right. And then you also might have a proxy. And then you might have an application filter. Now these are all specialized hardware. Right. Or it could also take other routes, like you can make it go through a VPN, and then you can have a load balancer. And you can have an application filter, right? Some of these are hardware based, some of these are not. The point here is, you see this IDS, IPS, VPN, all these things. They all consume some cycles of CPUs, and you can possibly, the input of one of these functions go to the other function. These are all network functions, right? These are all network functions. What if instead of all of these, you replace it by a very strong CPU, or rather a strong, very powerful computer? And on top of that, you're running IDS, proxy, app filter, firewall, VPN, load balancer, right? And this thing. So packets come in, and then the packets go to the appropriate network function, and then they go out here. So this is what is network function. This is what is network function virtualization. Okay. So this is what is network function virtualization. So if you want to look at middle boxes, more details about middle boxes, refer to RFC 3234. Okay. So when it comes to middle boxes, you can also say that these are intermediaries, right? And these are interposed in between the communicating hosts, right? Or rather, can also be called as a bump in the wire model. Why is it called a bump in the wire model? You remember, this is a keyword that we saw in one of the questions. It's because you have a router, you have a router, you have a router. Now the packet is supposed to go here without any interruption, right? But now if I keep a firewall here, right? So the packet has to go here and then go inside the firewall, then come down and then go out also, right? So this increases latency. So in a way, conceptually, you can say instead of going straight line, I'm going like this. It's a bump. So if you have to climb the bump and get down to the bump, it's going to take more time, right? So the extra time, it makes it looks like a bump in the wire, and that is why it is called a bump in the wire. And there are multiple uses for this also. Some uses are NATs, network address translations. We saw this in detail last time. And firewalls, of course. And then IDS. And then application. Okay, let's just keep it simple. Let's keep it to this much. You also have traffic shapers. All right. So, but what is the problem with it? What is the problem with middle boxes? It increases expenses, the operating expenses, and it limits extensibility and flexibility. So essentially, why this is the case, because we have to change anything in the box which it does not have. For example, if there is a new feature that you want and this box, this firewall cannot handle it. Let's say this firewall cannot handle it, and if you want that new feature, for example, filtering based on some new header field, this firewall is not equipped with. So what you do, you throw this equipment away and then you buy a new equipment, right? Because the code here that is running is closely coupled to the hardware. Because of this close coupling with the hardware, it cannot extend itself. So in a way, you're dependent on the OEM. This is the equipment manager, that is equipment manufacturer, right? And then you buy a new one. That is the reason why it increases expenses. Okay. And to buy a new one, that is okay. To buy a new one. But if you were using this model, right? If you were using this model, you don't have to buy anything. Just have to rewrite this code and deploy. And that's it. You'll be done. So this is one of the major reasons why network functions, network function virtualization came up. Okay. So this is the motivation behind NFV. Okay. So we'll just go over the NFV framework requirements. There is a body called ETSI. ETSI who has come up with NFV framework requirements. So what are the rules that you need to follow that you need to follow while pursuing network function virtualization? What are the rules that you have to follow? First is it must be general, right? It must be general enough such that it works for a myriad of cases, right? Second, it must be portable, since that if you write a piece of code and if you're running it on one CPU, you cannot say that it won't run on the other CPU. So basically, it means that there should be portability of the code that you write, which is going to act as the network function. Third one, performance. It must not be too slow, meaning it must meet a particular standard of packet loss rate or throughput, and supposed to support the specifications required for that particular network function. So then we go into some cloud terms, just like elasticity, security, resiliency, service continuity, service assurance, energy efficiency requirements, operational and management requirements, and transition. So I've taken this exactly from your lecture only. So elasticity means it needs to be scalable to meet certain service level agreements. And security means, you know what security means? It should not be compromisable. It cannot be compromised easily. Resiliency is basically fault tolerance. Right? So if it fails, it needs to be able to come back to the state at which it failed, and it needs to seamlessly start from there. So, and that these two are connected, seamless continuity. Basically, it needs to come back to the state at which it was when it failed, and then it runs from there. And then service assurance, which is the this is basically looking at post fault failure. Um, you have some packet marking schemes which help you detect what happened and where it happened, right? So service assurance and energy efficiency should not take too much of power also, and it should not be too much manual. It needs to be able to automate a lot of things without human intervention. And so these are all transition is pretty much means it needs to be interoperable among multiple vendor implementations. So it should also work with legacy implementations in the sense old packets should also work. Old format of package should also work with the current uh, code that is written for this network function. Right. So moving on from this, right, they came up with many architectures, and one of it was NFV, Nano Architecture Framework. So that is spoken about clearly in the lecture, right? You can take a look at the lecture if you would like to see this aspect of NFV. So other than that, you also have in the Mano framework, the Mano architecture framework, you also have something called the NFV orchestrator and VNF manager. Okay, so they have their own specific functionalities, and they manage the network functions. And what are these network functions? They are called virtual network functions. Right. So what are all the benefits of network function? What are the key benefits of going with this function virtualization? Correct. So let's talk about the benefits and let's move on to the questions. Reduce we already saw why there is a reduced equipment cost. Increase the speed of time to market. Uh, this basically means if you want to bring up something new, all you have to do is write new code and test it on the virtualized network function environment. You don't have to create new hardware. You don't have to manufacture that new hardware and sell it. So in a way, this supports innovation. third one is it encourages openness and coexistence of ecosystems. Right? Then it is also flexible, meaning if you want to increase the capacity of one VNF. VNF is a network function, virtual network function. And then just allocate more CPU cores to it. Right? Essentially, you can scale your network function. Right? So, and of course, it also increases operational efficiency. Okay. Now I think too much of theory. Let's move on to the questions. Just a minute, I'm just copying the questions here. Okay, yeah, what the question? Right. So, which of the following challenges is associated with network function virtualization? What are the challenges? Let's say, is there an increased network complexity and management overhead? Let's see. Is there reduced flexibility and scalability? No. It increases flexibility and scalability. Right? And does it lower security and privacy compared to traditional networks? No, it does not. There is no lowering or there is no increasing also, right? And is it higher cost? No, it is lower cost. So this is wrong, this is wrong, this is wrong. So this is correct. So basically, network function virtualization tends to have address the challenge of increased network complexity and management overhead, right? Okay. So the next is, what does the bump in the wire model mean? So we did see just now what the bump in the wire actually means. So where did this, in which context did this come in? This came in the context of middle boxes. Yeah. A bump in the wire because middle boxes take some extra processing time to put the packets out, and they are in the middle of different routers or different hosts. So it's like a bump in the wire, right? So let's see the options. A disconnected network for middle boxes. I don't think so because it's not disconnected, right? So this is wrong. Different kinds of wire to connect the middle boxes. No, not really. It's not different kinds of wire to connect the middle boxes. Also, it is a traditional mode of connecting the switches and routers. Is it a traditional mode of connecting the switches and routers? Um, nope. It has nothing to do with bump in the wire. And finally, middle boxes connected to the routers or switches increase the packet delay in reaching the source or destination. Yes, this is the answer, right? Because you see, you have a switch, you have a switch, then you have a middle box, right? And this middle box tends to increase the delay, right? Delay increased, all right? Therefore, D is the right answer. In other words, bump in wire produce additional latency. Third question, what are all the layers of operation the NFV addresses? Okay, so you have the layers, right? So as you were seeing, network layer and above. So this is the part that can be virtualized. Right? So is it only the physical and link layers? No. Is it the network and transport layers? It is, but let's see if there are any better options. Okay, it is actually um, only application layer. It's only there, so this is wrong. Network, transport, and application layer. So this is right. Because this is right, then you don't have to choose this, right? So this is for question number 3. So essentially, NFV is concerned with layer 3 to 7 functions. It is network layer and above, right? And once again, these could involve routers or firewalls, etc. Fourth question, what is network function virtualization? Is it a protocol used for wireless communication between devices? Absolutely not. Is it a technology that virtualizes network functions into software? Yes. This is what we basically saw, right? Is it a technique used to encrypt network traffic for security purposes? Nope. It can be used for security purposes, but it is not, as it is only a security function. Right? And then the technology responsible for monitoring network traffic. Responsible for monitoring network traffic. No, this is also a very specific use case. So the answer is yeah. So let's look at question number 5. So what is the difference between network function virtualization and software-defined networking? And NFE is focused on separating the control and data planes in a network, while SDN is focused on virtualizing network functions. Right. So they're asking what is the difference between NFV and SDN. Let us see. NFV is focused on separating control and data planes. No, right? It is NFV does not do that. SDN is focused on virtualizing network functions. No, it's completely wrong. NFV is focused on virtualizing network functions, while SDN is focused on separating control and data planes in a network. Right. So option B is correct. NFV and SDN are the same thing? No, they're not. NFV is a hardware-based approach, while SDN is a software-based approach. Wrong. NFV is a software-based approach. Right. Correct. So the answer is B. So which of the following statements are correct about network functions? About network function virtualization. So network function virtualization eliminates the need for hardware changes when network requirements change. Yes, because if you want to change something in the way the network function works, just need to rewrite the code and recompile it and push it. That's all. You don't need to change the hardware, right? So there is no need for hardware changes. It eliminates the need for hardware changes. Yes, the A is correct. The role of virtual network function, VNF, is nothing but a network function, which is running in software. The role of a virtual network function in network function virtualization is to centralize network control in a virtual environment. to centralize network control in a virtual network. This is the job of a controller, right? It is a part of SDN. So this is not the case. We're not trying to centralize anything here. We're not trying to centralize control here. We're not. So network function virtualization is the ability to run multiple virtualized network functions on a single hardware server. Yes. If you remember the diagram that we drew here, you see single powerful server or a computer is running multiple network functions. So that's pretty much what this. So that is pretty much what this statement says. So it is correct. Again, virtual network functions enable network operators to implement network functions using dedicated hardware devices. So the key here is dedicated hardware devices. We are moving away from this, not towards this. NFV moves away from dedicated hardware devices. So this is wrong. So the answer is A and C. So if you take a look at the lecture, you will find a diagram where the functions of the operating support system are. So this is basically a part of the architecture, the HC architecture. So here, the operation support system, does it, is fault management a primary function? Yes, it is. Is configuration management? Yes, it is. Is performance management there? Yes, it is. But customer management, it's not. Customer is something else, right? So that's pretty much what this is. This is directly from theory. You can just go and take a look there. So again, just the following statements are incorrect. Okay, so we saw something called the Mano layer, right? So the virtualized infrastructure manager is a part of the NFV management and orchestration layer. So this is not really correct. If you see the diagram, you'll understand. Right? So the NFV management and orchestration layer is responsible for managing the physical network devices. Yes, that is the work of the Mano layer. Correct. One of the works of the Mano layer. And the NFV infrastructure manager is responsible for providing physical resources for the VNF. No, that is not what the NFV infrastructure manager does. Infrastructure looks at the infrastructure. So it's not the case here. So the management and orchestration layer is responsible for providing the virtualization layer in NFV architecture. So this is, yes. So basically these things, they're coming directly from the diagram that was explained in the class. So you can take a look there for more clarity on this, right? And next question is, which network function virtualization component is responsible for the automated provisioning of virtual network functions? So something called automated provisioning. Um, if you, the answer is D, that if we are orchestrated, just from the diagram only. So by provisioning, it means you write a VNF, right? Some component has to allocate some resources and provision this VNF, right? in the NFV environment. Right. One of these things, one component has to do it, and that is done by the NFV orchestrator. That's the answer. Similar to that question, here we have which network function virtualization component is responsible for managing the life cycle of VNFs. Which of the VNF component is responsible for managing the life cycle of VNFs? This once again comes to the VNF manager. This is directly from the diagram with explanation. So basically here, the VNF manager is responsible managing the life cycle of VNFs, including deploying, configuring, scaling, and decommissioning VNF instances. All right, so this live session is coming is at the end right now. I'm cutting it slightly short because I think we've finished all the 10 questions and it is not good. So sorry if I was not enthusiastic enough today. So we'll meet again next week and I'll be here till 8 o'clock. If you have any questions, you can ask. Else, you're free to leave the call. Right? Okay. Thank you.